limits.
Limits, correct? So already we have started the limits and we have seen some basics of the limit. We have solved some examples as well, correct? Basic
Yes, sir.
examples. I'm not going to be solve example based on the trigonometric functions because it is quite difficult. Those who came from the non-mathematics background, if people were interested, we can do that also separately. Okay. So, but there is no need to go for the trigonometric and some special kind of the example which is based on the exponential functions, logarithmic functions. Okay. That's why only I am solving here only polynomial functions. Okay, my concentration is here on only polynomial functions because if you see the more examples or more equations in your economics are polynomial functions, right? That's why I'm concentrating more on the polynomial functions rather than exponential and trigonometric. Okay, let's move to the next concept called as a continuity or continuous function, right? When we can say that a function is a continuous function. So if you want to define this by using the graphical method, it is very easy to define when we can say that this function is a continuous. Again, continuous is a point property. Okay, it is a point property. We have to say that the particular function is continuous at particular point. If we want to say that a function f is continuous at a point E, then what are the criteria that function has to be satisfied? When we can say that the function is continuous. If you want to say the graphical method, it is very easy. If the graph of that function is like this without break, then you can say that that particular function is a continuous function. And suppose if the graph having like this some gaps, okay, or some holes, and then it is a, like a like this, then this function is not continuous at this point. It is not continuous at this point. Means what? It is not continuous means what? It is a discontinuity of the particular function at that point. That is called as a discontinuity. Suppose it is a or a b, and these are the graph of function f of x and graph of the function g of x. If your function is continuous, if straight away we can say that its graph should be a continuous. Otherwise, you can say that the particular function g of x is not a continuous, or you can say that it is a discontinuous at the point AB. Suppose it is defined on the interval, suppose A to some another point C. Okay. So again here, that's why we are saying this the point property. A function f of x is said to be a continuous, is said to be continuous at a point x is equals to c or x is equals to a. We take x is equals to a if first limit at that point should be exist. Limit at that point should be exist. Okay. What is the second? Limit at x tends to c minus of the function is same.
Right hand limit is equal to left hand limit.
Correct. And which is same as at a point. Okay. Third, you can say that limit should be same. This has to be means if suppose it is f of a, right? This limit has to be same with this limits. Okay, it is equals to f of a. I will write here. If your function is satisfying these things, these criteria, then you can say that that particular function is continuous. at a point f of x is equals to at a point A. Okay, there is another definition, mathematical definition. I will not go in that, where you can use the another f of x minus f of a is less than epsilon, where x minus a is less than delta. So it has a different meaning. I will not go in that because it will take in another direction. But I'm not interested to see that definition. Only we will see either for our understanding of the graph of that function is continuous, then you can say that that function is continuous on that particular interval or on that particular domain. And if you want to see that particular function is either continuous or not at that point, then it should satisfy these conditions. Okay, let us see few more examples based on this definition. Let me check few examples. You can check their continuity at that point. Check the continuity of the function. Check the continuity of the function. Then if the function f of x is defined as, if it is a x plus 2 when your x is less equals to 4, and it is x plus 4 when your x is greater than 4, so you have to check at the x is equals to 4. Okay, so first what we have to check, we have to check the limit at this point or not. Okay, so I think there is no any ambiguity between that. So first let's check the left hand limit and right hand limit. Limit as x tends to, because I think it is given or not, it is not given at all. So limit as x tends to 4 minus of a function f of x is equals to limit as x tends to 4 minus. So when your x is less than 4, means we are approaching 4 to from the left side. So which function we will choose? Which function we will choose if we are approaching
X
4
plus
by left side?
x plus 4. The second one.
Huh?
X plus 4. The
X plus
second one. F of x is equal to x plus 4.
Okay, let me clear again.
Oh, sorry. X is less than 4 you were saying, na? So x plus 2.
X plus
2.
2, right? So then it will become 6, and limit as x tends to 4 plus f of x is same as limit as x tends to 4 plus sorry, x plus 4, and it is again 8. Therefore, limit as x tends to 4 minus of a function f of x is not equals to limit as x tends to 4 plus of f of x. Okay, what does it mean? What does it mean? The left hand limit is not equals to right hand limit. Means what? Limit is not exist. Okay, therefore you can say that directly the function f of x is not continuous. The function f of x, the function f of x is not continuous. Is it visible what I am writing? At the x is equals to 4. Is it clear? Just we have to check either limit is exist or not. If it is exist, the right hand limit or the left hand limit should be same. And if you put f of x is equals to 2 at a 4, means it is included here. It is f of x is equals to, if you can put 4, so it is x plus 2 means it is a 6, and that value should come same with this. Then you can say that that function is continuous, but it is not happening here. So that's why we say that this is not a continuous function at a x is equals to 4. Let us see few more example based on this. Can I remove this?
Sir, wait.
Yes.
Sir, wait one minute.
Yeah. I will not remove that part. I will remove this, and meanwhile I will write few more example. We have to check the continuity of this function. It is defined like this: x square minus 1 upon x minus 1 when your x is different from 1, and it is a 4 when x is equals to 1. Meanwhile, once your writing is done, let me know. It is same kind of the example, little difference is there. F of x is equals to, it is the defined x square minus 4 and x minus 2 when 0 is strictly less, it is less equals to x, it is less equals to 3, and it is 3 when x is equals to 2. Okay.
Sir,
Yeah.
hello?
Yes, please.
Yeah, you can have it, sir. It's finished.
Thank you. So this is a little different kind of example. There are so many examples, different kind of examples you can find, but the concept has to be clear. That's why either you can go for one example or multiple example, doesn't matter, but your concept has to be clear. That's important. Okay, let us see for this example. So we have to check the continuity of this function, which is defined like this at x is equals to 1. Okay, so means what? What are the given things are here? If you can see, f at 1 is given you 4. Okay, now we have to check the limit, right hand limit and uh, left hand limit as x tends to 1 minus of function f of x. So which function should I choose? Yes, which function?
X square minus 1 divided by x minus 1.
First one.
Yes, sir.
Okay, so now what will be the next step?
Simplify.
Okay, so if you can see, if you can observe this numerator, you will get to know that this is like this, right? This is similar to this one, right? So we know that this is a minus b and a plus b. Okay, we'll use this. So here it is the same limit as x tends to 1 minus x square minus 1 square upon x minus 1. So that is same as x minus 1, x plus 1 divided by x minus 1. So these same terms will get cancelled. And what will be the remain? Limit as x tends to 1 minus of x plus 1. So this is same as it is 2. So let us try for the right hand limit as x tends to 1 plus of function f of x, and which is directly defined as 3. Now, if you can see here, limit at a point is a different, but left hand limit is different than right hand limit. Therefore, limit does not exist at this point. Therefore, the function is not continuous. Therefore, function is not continuous at x is equals to 1. Okay, or you may write that function is discontinuity, having a discontinuity at x is equals to 1. Both statements having the same. Similarly, you can try to solve this example at a x is equals to 2. Let me see little different examples are there or not. You please write down this example for an homework. So I will change this first example and we can see. Can I remove this part? Can I remove the example number 3?
Yes, sir.
Okay. So we'll see one more example and then we will go to the next answer. It's defined in such a way that we have to check the continuity of this function f of x is equals to x square minus 2 when your 0 is less equals to x is less equals to 2. It is 2x plus 3 when 2 is strictly less than x is less than equals to 4, and it is x square minus 5 4 strictly less than x is less equals to 6. So we have to check the continuity of this particular function on two different points. Here you have to check at x is equals to 2. Here you have to check at x is equals to 4. So first we'll try to check at x is equals to 2. So therefore, what will be the value of a function at x is equals to 2? At x is equals to 2, what will be happen? F of 2 will be what? When this 2 is included in any one of this in this function, correct?
Square minus 4.
2 square minus 4. So it is a 0, correct?
Yes.
Okay.
Yes.
So we go for the left hand limit. Okay. Left hand limit. Limit as x tends to 2 minus of a function f of x is same as limit as x tends to 2 minus. So which we can take? Again, this same we will take x
First one.
4, which is again 0. Now we can take the right hand limit. Limit as x tends to 2 plus of a function f of x is same as limit as x tends to 2 plus. So now which function will choose?
Second.
2x plus 3. So it is 2 into 2 plus 3. So it is 4 plus 3. It is 7. So therefore, left hand limit is not equals to right hand limit. Therefore, function f of x is discontinuous at is equals to 2. Okay, let us move for the second part. At a x is equals to 4. So at x is equals to 4, what is the value of the function f of 4? It is 2
2x
into 4 plus 3. It is 8 plus 3. It is
11.
yeah. So what is the value at f of x is equals to 4? Is it 11? I'm audible? Hello, Aditya?
Yes,
Hello?
sir.
Yeah,
Hello, sir.
okay. Uh-huh. Yeah, because I don't know what happened exactly, it was disconnected. So, so what is the value of this function at x is equals to 4? So we'll take this function 2 into 4 plus 3. So 8 plus 3 it is 11. So let us take the left hand limit. Left hand limit. So limit as x tends to 4 minus of a function f of x is nothing but limit as x tends to 4 minus. So which function we can choose? We can choose same as 2x plus 3 and which will be 11. So what will be that right hand limit? Limit as x tends to 4 plus, right? Of a function f of x is same as limit as x tends to 4 plus. So it is x square minus 5. So this is nothing but 4 square minus 5. What is the 4 square? Is it 16? 16 minus 5 is again 11. Okay. So if we can see the function at the x is equals to 4 is 11. Right hand limit is same as the left hand limit. Therefore, function f of x continuous is continuous at the x is equals to 4. Is it clear? Is it clear this example?
Yes, sir.
Okay. Thank you. So can I remove this part? Can I remove this part?
Sir, I have one question.
Okay.
Sir, can you explain why we put the value like x equal to 4 in the beginning? At the first line, sir, like at x equal to
This
4.
one, this one.
Yes, yes,
Why you want? That is your question, or
yes,
how?
yes, sir.
See, as per the definition, what we want limit has to exist one, and if it is exist, the value at that function value and limit value should be same. Function value and limit value should be same. That's why what we did, we were interested to check the continuity of this particular function at the x is equals to 4. That's why we kept in this function at the x is equals to 4. But if you can see, the function is defined in such a way that this value, this function will take this value when your x is lies between this interval, right? And it will take this value when your x is lies between this. So for x is equals to 4, this 4 is included in this interval. That's why we have taken the value of the function f of x is equals to 2x plus 3 here. And we have put it x is equals to 4 in that. And we have checked the value of that function at x is equals to 4 and which is equals to 11. Is it clear?
Yes, sir. Okay.
Okay. Yeah. Can I remove this part? Can I
Yes, sir,
remove
you
this
can.
part? Okay. So similarly, the algebras, what are the algebraic operations, or you can say algebra of the limits we have seen. Similarly, it will satisfy in a when your function is a continuous. If function f of x and g of x are the two functions, and these are the continuous function, then uh, if they are continuous, limit as x tends to any point c f of x plus g of x. These are the continuous function. Then it is the same as you can say that limit as x tends to c f of x plus limit as x tends to c g of x. The same properties will satisfy for the addition and subtraction, because these are the this definition of the continuity is based on the limits. So that's why the algebra of the continuity is also satisfied. So I will not go for that. So now let's move to the next. Uh, should I write few more examples for an exercise, or should I upload on the Moodle?
So you can write it now.
Yeah. Okay. Let me write few more examples. You have to check the continuity of these functions. Say function f of x is equals to x cube plus 3x plus 5 upon x cube minus 3x plus 2 on this interval 0 to 5. Okay. Second, say f of x is equals to x square plus 1 upon x minus 2, where your 0 is less equals to x, which is less equals to 3, and it is 3x minus 3, 3x minus 1. It is 3 is strictly less than x, which is less equals to 5. The next is function f of x is defined in this way. It is x square minus 2x minus 3 upon x minus 3, when your 0 is less equals to x is less equals to 4, and it is x square minus 1 upon x plus 2, when your 4 is strictly less than x is less equals to 6. And one more example I will write. The function f of x is defined in this way. It is x square minus x minus 6 upon square minus 2x minus 3. X is different than 3, and it is 5 by 7 when your x is equals to 3. You have to check at x is equals to. So these are the few examples for homework. Okay. So please write down these examples, and then we can move to the next part of the syllabus. Can I remove this? Is it done?
Yes, sir.
Okay. Okay, we'll move to the next concept. Okay. So derivative. So why we have to study the derivative? That is one of the important questions in front of us. Actually, limit and continuity we used to study to get the detail about the derivative only. Okay. So limit and continuity is based on the derivative. Okay. Uh, why we have to study the derivative? That is the important. What is what derivative will you? Derivative will give the rate of change. What derivative will give? Rate of change of one variable to the another variable. Right? Derivative will provide you rate of change of one variable to the another variable. There will have two variables x and y. One will be dependent, another is called as independent. Okay. So can anybody will tell me why we have to study the derivative? What is the meaning of the derivative? Quickly and just brief. One sentence is sufficient for me. Yes.
Sir, in simple words, like
Hmm.
the function is like a wall and there is a hole. So the limit is used to find the hole and the derivative is used to fill the hole.
Feel that?
Hole.
I need more, little more.
Sir, I said it in simple words.
Yeah, yeah. You said simple one, but I require little.
In mathematical sense, it is to derive the formula of the function or the number.
Mhm. Uh, Before that, so we'll see why we have to study the derivative. What is the need?
Sir,
What is
like
your
in a
understanding?
function, there are many points. Like in a function, there are many points, and the derivative is used to find a number on
Hmm?
that function or graph.
You are close, but you are not telling correct answer. You are close to that. I think you might be clear about it, but unable to express it. Anybody can give the response about this? Yes. So, okay, let me try. So, what is this? What this represents? Yes. What this represents?
It represents a function. It's a graph of a function.
Yeah, more precisely. Okay. This is another function. Okay. But what is the difference between this and this function? Is it there difference?
fx is like constantly moving and gx is parabolic.
Okay. So you said it is parabolic. Okay. So what about this? F of x? What what you will call this?
Straight line.
Yes, straight line. Correct. Okay. It is straight line. Now, so what is this? She already mentioned that it is moving with this constant change, right? So what is this? This is a constant throughout
Slope.
this line, correct? What we call it is
The constant slope.
slope, correct? This is called as a slope. Okay. Now, in a straight line, it is very easy to find the slope. Means, what exactly will give the slope? Slope will give the delta y upon delta x. What is this delta? Delta usually
Change
we use. Yes,
change in y with
correct,
respect to change in x.
correct. Means generally we uses the delta. The delta meaning of the delta means small change, very small change. So slope will give what slope will give here? Change of y with respect to x. If your x is varying, how y is varying, right? This is f of x is nothing but a y, correct? When your x is varying, how y is varying with which number? This is again some constant or some we uses it as a young. Correct? So the slope will give the rate of change of y with respect to another variable x. And in this variable, we will call it as this is a dependent variable, right? This is dependent variable and this is independent variable. Independent variable. So the value of y is depend on x. That's why we call it as dependent and this is we call as independent. So rate of change of y with respect to x is a some constant number. Means however you will go up to 100,000 1 crore, the rate will be the same, right? So what about this graph? What about this graph? G of x. Can we have same slope here?
No, sir. At each point, it has a different slope.
Correct. So then how we can find the slope of this point? Because we are this graph of this g of x means it is a solution of some function, a solution of some problem, correct? The graph of this is suppose someone you say some product function graph or some demand function graph. To understand this, we want to we are interested to see their rate of change, correct? We are interested to see the rate of change. That's why we are also interested to see the slope of this. So how we can find the slope of this particular function g of x,
Through derivative.
right? So whenever your function is a non-linear function, whenever your function is a non-linear function, at that point of time, we cannot use the concept of a, slope of straight line or a slope of a, your linear function. So that's why we will use the another concept that is called as a derivative, right? So what we are doing like because if you can see here, if you can see this graph is like this. If I will take this closed part, if I can take this closed part, these two parts, now this section is what? If I can take the small parts of these, so what this represent? This small part, this small parts. Is it line?
Numbers, points.
No, no, no. Sorry, I want to tell that if you can take very small 2 points, right? Then it looks like a line. Suppose if
Yes,
you
sir.
can see in your mobile, right? If you can zoom it, if this curve is there, if you can zoom on this part, so that will look like a line. Is it correct? If you can take it on your mobile and if you try to zoom it, so this curve will remove and it will looks like a line, correct? So that we can use the definition of slope. We can use the again definition of the slope. So in another way, we are defining the slope for the non-linear functions. Derivative means what? It will give the slope of the non-linear functions. All right. So suppose there is a function, say here, say now it is g of x. So it is, if this point is x, and if we can take this point, it will be x plus h. H is what? H is very small difference or any small positive quantity. So now corresponding to this, there will have function f of x and f of x plus h. Now we can define the derivative of a function at a particular, and generally we denote that as an f dash x because it is a rate of change. Somewhere you may find that df by dx, right? Somewhere you find the notation like this dx, right? So it is defined like that, f of limit limit x, sorry, limit h tends to 0, f of x plus h minus f of x upon h. So now if you can see, this is again, what is this? This is the difference between these 2 points. You know the slope point formula, that only we are using here. So derivative is nothing but the generalization of your again slope, nothing else. Your concept of the slope you are using for the linear functions, while derivative is useful for finding the slope of non-linear functions, right? So the derivative of function f of x is generally denoted by f dash x and df by dx. This is nothing but rate of change of a function f of x with respect to x. Or else you can write dy by dx, it is the same. So it is defined as limit as x tends to 0, f of x plus h minus f of x upon h. Is it clear? Is it clear?
Yes, sir.
Yes, Kushi, is it clear?
Yes, sir.
Why we have to study the uh, derivatives? So we'll see the few. Can we have a break and then we can back? Do you need break or not?
Yes, sir.
Yes, sir.
Okay, let's have a 5 minute break. Then I will back again. Right. So we have defined the derivative in this way. Generally, we denote the derivative either by f dash x or a df by dx or a dx, and it is defined in this way. Okay. So let us see two more basic rules of the derivatives. Is it clear the definition of the derivative? Yes. Is it clear? Yeah. 1 minute. One minute. Let me join again. Okay, so meanwhile we'll start how we can find the derivative of the different functions by using the definition of the derivatives. Okay, find the derivatives of the following function. Following function. First, say f of x is equals to x. Say second, f of x is equals to some constant k. Okay, let me write another f of x is equals to x square. These are the basic functions. We can see how to find the derivative by using the definition of the derivative. We call it as a principal definition of the derivatives. So uh, given that, what is given? Given that f of x is equals to x. Okay. So we know that, what we know that, we know that f dash x is nothing but limit as h tends to 0, f of x plus h minus f of x upon h, right? Okay. So therefore, so what is f of x? F of x is given here. So here, what is f of x plus h? Yes. What will be the f of x plus h?
X plus h.
Is it visible? Okay. Is it visible what I am writing?
Yes, sir.
Okay. Therefore, so we'll put all these values in this definition. Therefore, f dash x is equals to limit as h tends to 0. F of x plus h, it is x plus h minus what is the value of f of x? Is x upon h. So this will get cancelled. This will get cancelled. So it is remained as limit as h tends to 0, h upon h. So this will also cancel, so 1. So the derivative of f of x is 1. So what is the derivative of f of x is equals to k? Again, we will solve the same example by using this. Can I remove this?
Yes, sir.
No, sir. 1 minute.
Or
Wait,
should I
wait.
write here? Okay, here I. So here your f of x is equals to some constant k. What will be f of x plus h? What will be f of x plus h?
K plus H.
What? What will be f of x plus h?
K plus H.
K plus h? How? Is there any x is here?
No,
Then how you are adding h? Because
Then it will be K only.
it will be k only. So let us put all these values. Can I remove this part? Hello.
No, sir. Wait, sir. 1 minute.
So I'm having little network problem. That's why this disconnection and all these things are happening.
So can you move a little bit?
Yes.
Sir, can you explain the last line?
This one.
Yes, sir.
Or this. So what I did in this example, your function f of x is equals to p, means constant. So it is independent of x. There is no value of x here, right? So whatever your x, that function will take the value k only, right? So f of x is equals to k. F of x plus h also will be k. So now we'll use the definition of this derivative. F dash x is equals to limit as x tends to 0. F of x plus h is k. F minus f of x. So k minus k is 0 here, right? Means
Oh,
what?
yeah.
Derivative of any constant function will be 0,
Yes,
right?
sir.
Any constant.
Sir, yes, sir. Understood, sir. Yes, sir. Thank you.
Okay. So can I remove this part?
Yes, sir.
Okay. So now you can see here, we'll go for this example. F of x is equals to x square. So f of x is equals to x square. Then this is the definition. So what about what we want? F of x plus h. F of x plus h is nothing but x plus h bracket square. Correct? So let me expand it here. X square plus 2xh plus x square. Now we'll use the definition of derivative f dash x. F dash x is equals to f of x plus h minus f of x. I need to write here as h tends to 0 divided by h. So this is same as limit h tends to 0. What is f of x plus h? This quantity. So it is x square plus 2xh plus h square minus what is the f of x? It is x square divided by h. So this terms will get cancelled with this. So what is the remain limit as x tends to 0 to x plus x square divided by h. Let me divide this term by h again and then we'll take the limit. So limit as h tends to 0 if I will divide each term by h. So what will happen? It will be 2x plus h, correct? This h is cancelled with this h is cancelled with this, from this only one terms will be remain. So if you can take the limit, so what will happen? This will become 2x. Means derivative of x square becomes a 2x. Derivative of x square will become a 2x. So in general, we have the formula that in general we have formula for the power function. We call it as a power function because it is a power of some polynomials. Power function. If your function f of x is equals to x raised to n, then derivative of this is n into x raised to n minus 1. So if you are interested to see how it will come, so I am ready to derive, but I feel it is not that much of necessary. What should I do? Should I derive this, or you will take directly as a formula? Yes.
So can you say again?
What I say, suppose this is the general formula for finding the derivative of function, power functions. If your function f of x is equals to x raised to n, n means any power, right? It is a any power, right? It may be 2, 3, 4, 5, 100,000 crores, no problem, right? If your function is in this way, then its derivative will become n into x raised to n minus 1. So you can see here, if f of x is equals to x square, then its derivative become 2x, right? If you are just, we have seen that f of x is equals to x, then its derivative become 1, right? So you can use this formula and you can find out the direct this solution, right? So similarly, can you tell me what will be the derivative of this function f of x is equals to x cube? So here you are
3x
getting
square.
3x square.
x square. So by using this formula, you can find out derivative of this power function immediately. If I was asking, do you need how it came, or you will take it as a directly as a formula? If you require, I can derive that also. How it came.
Sure.
Hmm? Do you need that?
Yes, sir.
Okay, so that's why you required again a binomial expansion of the two variables. If you want to
Sir, what was the chain rule system? I
chain rule,
forgot.
surely. Yeah, we are going to see that chain rule as well. It is not, it is just a product formula. Sorry, power
This is
function formula.
chain rule, right?
Huh?
So this formula, power function formula is a chain rule, right?
No, no.
Okay.
Anyhow, we are going to chain rule. Then you tell me what is the difference between power function formula and chain rule. Okay. Chain rule require another mechanism, means another things will be required. Can I remove this part? Okay. So should I derive this formula, or should I go for the next? Okay. So we will go. This is the power function. Then we will go to the sum rule. Sum rule means what? Addition of the two functions. If u of x and v of x are derivable function, means derivative exists, derivable or a differentiable function, you can write, are differentiable functions, differentiable functions. Okay, then then uh, Then I want to say the product. Then d dx of u of x plus v of x is same as d dx of u of x plus d dx of v of x. Is it clear?
Yes, sir.
Hmm? Or simply you can write this same as ux v of x raised to dash is same as u dash x plus v dash x. So this is we called as some rule. Difference rule means what? You just subtract here. That will be a difference rule. That will be difference rule. Means what? For example, suppose a function, we can define some function, say f of x is equals to 3x square plus 2x plus 3. So it is addition of the two functions. If I will treat this as a one function, this is supposed to be your u of x and supposed to be v of x. Find differently and do together. The value will come same. Also, I will write one more directly, or you can do by this. If your function f of x is equals to e raised to ax, then its derivative f dash x is a into e raised to x. So these things you keep in mind. Okay, let a be any constant. Similarly, this now we'll go to the product rule. It is very important. Okay, we'll go to the product. What it will say if u x and v of x, if u of x and v of x are variable function, then d dx of u of x into v of x. Okay, what will it will come? This is nothing but take the derivative of first function d dx of
U of x
x, keep v of x as
into v
it
of
is,
x plus
plus
v of x ddx of
plus
u of x. U of x ddx of v
into.
of x.
Okay, this is called as a product rule. You can use the definition of derivative and you can prove this. Okay, let me remove this part. Please note down this one formula, and this one formula. These are the very important. So let me go to the next. This is what some rule is there. Okay, can we do some exercise? Product rule. Then there is called as a division rule. What is the division rule? What is the division?
Sir, ddx of u of x into v of x minus v of x into ddx of uh, u of x.
U of x upon v of x. So what it will come?
Sir, sir,
Yes.
ddx of u of x into v of x minus u of x into ddx of v of x divided by u of x squared. Somewhat like that.
U of x here u of x will come. Here will be v of x and divided by p of x bracket square. Or in short, you write this as in this way: u upon v. Suppose these are the functions of x only. So it is u dash into v minus v. Sorry, minus u into v dash upon v square, which is the very easy to be remember, right? So now can we do little some exercise based on this? Can we do some exercise based on these formulas?
Yes, sir.
Yes, sir.
Okay. Okay. Find the derivative of a function. Find the derivatives of the following functions. So what are these? First, say the f of x is equals to say x square plus 2 into x plus 3. Okay. Second, say g of x is equals to x square plus 2 into under root x. And third, say h of x is equals to under root x. So x plus 1 into e raised to minus 2x. Okay, let us solve these few examples. Let me solve first one. So what is first one? Given that what is given? F of x is equals to x square plus 2 and x plus 3, right? So we will consider it as consider u of x is equals to x square plus 2 and v of x is equals to x plus 3. So what will become here? What will be the u? We will use the power function. So this whatever the power that will come to the product and power will be reduced by 1. So it is nothing but 2x. Derivative of constant is a yes. Derivative of constant is
0.
0. So derivative of x is
1.
1 and plus the derivative of 3 is 0 because it is a constant. Now we can use the product rule formula. What is that product rule formula? U into v dash is nothing but if first function as it is, take the derivative of second plus if second as it is, take the derivative of first. So we can use that. Therefore, f dash x is nothing but keep first as it is means this as it is x square plus 2 as it is. Take the derivative of second. Derivative of v dash x is 1 plus keep first as it is x square plus 2. Take the derivative of I did mistake. No. First as it is derivative of second. Second as it is derivative of first. Yeah. Second as it is and take the derivative of first one. Right. So u dash is it is 2x. So this is the f dash x for this function. Is it clear? First, is it visible?
Yes, sir.
And is it clear how to find the derivative of such a product functions? Remove. Is it clear? Can I remove this?
Yes, sir.
Okay. Should we move ahead or should we stop?
Sir, do we not need to simplify the equation at last?
Not necessarily. If you can
Okay.
you can do the manipulations. So what will happen? This 2x square plus 6x. So 2x square plus x square, this will become 3x square. 3x square plus 6x plus 2. This will be the final answer. But if you can keep it here only, no problem. That's fine for me.
Okay.
Okay. So we'll do only the chain rule and we'll stop it. Okay. So you can do this rest of this example by using the chain rule. And one more example we'll see here and then we'll stop. Can I remove this part? So we'll do one example for this division rule and then we'll stop here. So you do, let me write Is it visible? What is on the board?
Yes,
Yes, sir.
sir.
So what is here? U of x is equals to x square. What will be u dash x? U dash x will be, yes,
2x.
it is 2x. And what will be v dash x? 2 into 2, 4 x. 2 minus 1 means it is x, plus derivative of 3x is 3 and derivative of 2 is 0. Okay, so what will be derivative of this function, particularly f dash x? So f dash x is nothing but, first you have to take u dash. U dash is your 2x. What will be the p? Keep p as it is, 2x square plus 3x plus 2 minus u as it is, so your x square as it is. Take v dash x. So what is the your v dash x? V dash x is this, 4x plus 3 and divided by v square. So what is v square? This is square. So 2x square plus 3x plus 2 bracket square. In this way, you can find out the derivatives of such a function by using the division rule. So let us move to the last rule called as a chain rule. So you can practice by your own, just change the functions. You can take here under root x, and you can take here e raised to 2x, 3x minus x plus x, or else you can do here like x plus 2 divided by under root x. So you can use these different functions and try to find out the derivatives. By using these formulas itself is sufficient to me. It is a check. So suppose there is a function u is dependent. We are interested to find the derivative of, interested what? We are interested to find the derivative of f with respect to x. So what you will do? F dash of x is nothing but, we'll find the derivative of uh, f with respect to u, and we'll find the derivative of u with respect to x. So this is nothing but a chain rule. Is it clear? What is the difference between chain rule and power function rule?
Sir, can you repeat again? The video was lagging.
This one?
Yes, sir.
Yeah. So what is here? So f is depend on u, and u is a function of x. So we are interested to find the derivative of this function with respect to x. With respect to x. So in this case, so how we can find derivative of f with respect to u, derivative of u with respect to x. So you will get the total derivative of f with respect to x. So let us do one example for more clarity. Suppose a function is like this. Find the derivative of following function. Following function. Say first f of x is equals to under root x square 3x square plus 2. Okay. So how we can use here chain rule like this? We'll solve this example in this way. That to 3x square plus 2. Now we'll substitute, put u is equals to 3x square plus 2. Okay, we'll put this is equals to this. Now what will happen? Therefore, f of x will be converted into this under root u. Okay. So now we'll find first what? Derivative of f with respect to u. Means what? Derivative of this. So this is the same as what? This is nothing but u raised to 1/2. Right? So what will happen? 1/2 into u raised to
1 by root
1/2 minus 1. So this is nothing 1 upon u raised to minus 1/2. It is same as 1 upon 2. So if you can take this down, so it will become
root over
under
u.
root. Right? Similarly, for this, what we want? We want du by dx. So let's find that also. So du by dx. So derivative of u with respect to x. So what is that? That will be 6x. So therefore, df by dx is nothing but df by du into du by dx. So this is same as df by du is known to you 1 upon 2 under root u. You know the value of u, so you can substitute that value 3x square plus 2 into du by dx. Du by dx is 6x square. 6x square. So this cancel with this. So it is 3x square upon under root 3x square plus 2. Is it clear?
So it
Yes,
will be
sir.
6x, not 6x square.
It is,
I think
correct, 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 correct. One will be reduced. Yeah, you are correct. 3x. Derivative of u dash, derivative of u is 6x. It will be reduced to 1 power. Correct. Thank you. So is it clear?
Yes, sir.
Okay. So you can try to find out the similar way g of x, derivative of this function under root e raised to minus 2x. Okay. Some h of x is equals to I can give more if you want more complex 2x into x square plus 3. Okay, like that. So we'll stop here and just while coming next class, you just read what is the marginal revenue, what is the total revenue, how you will find the marginal revenue by using the derivatives, right? So these are the few applications you can use in your economics part. Okay, anyone have any doubt?
Sir, can you move aside for 1 minute?
Yeah, that. Okay.
Okay, sir. Thank you.
Thank you.